We are going to start off our year with a few kind of tidbits about the notes and then just a little bit of vocabulary today. I'm not going to start you off too in depth, but I do want to get some vocabulary down, explain to you a little bit about your notes, and then explain to you just a little bit about your expectations, I guess, or how to better yourself, especially while you're at home right now, throughout the year. Set yourself up for success. So when we look at the notes themselves, they have a PowerPoint format like this. They're always in Schoology, whether we're at school or you're at home. I always have the full PowerPoint in Schoology. This year I'll be voiceovering just like this format, so that way if you are absent or if you are just an at-home student, then you will have me teaching you about the notes and hopefully hear some of the stories and some of the demonstrations that I would normally do when we were face-to-face. So as we're looking at chemistry itself, as far as the class goes, it does keep building on each other. So as chemistry builds on each other, you're going to want to make sure that you know the information. What we learn in the first part of the year, it builds and builds and builds until we get to second semester. I always kind of talk about it's like a kindergarten class where first you work on just your letters. And then once you look at the letters themselves, then you start to put them together and make words where you're reading the words. Then you take those words and you put them into sentences. Maybe not in kindergarten, maybe it's later on down the road, but this is all in one class. So what we are actually going to do is we're going to look at just the basics of chemistry first. After we look at the basics of chemistry, then we're going to look at just the elements themselves in atoms. Then we're going to build those together and we're going to make chemical compounds, like words. And then we're going to look at chemical reactions. So we're going to build upon all of this. So the chemistry itself doesn't really go away. I know in other classes, once you learn one topic, then you can kind of move on with your life and you never have to think about it again. That is not the case for this class. So you want to make sure that you're staying on top of your studies and you want to make sure that you're not falling behind. If you do fall behind, you're going to have to backtrack and learn the old stuff before you can move on. So that all being said, as you have your notes, there is a Word document that you can print if you want to. Or you can write these on a separate sheet of paper, but I highly recommend that you go through and actually physically use a pen or a pencil and write out your notes. Your brain does better when you actually write out the words, and you actually do even more as far as that putting it into your brain when you actually say it out loud, especially to somebody else. That's why a lot of times teachers say, hey, teach this to a partner. They're not trying to torment you. It's because when you say things to somebody else and you try to teach them, you retain the information more. So, that all being said, when you see the note sheet, you'll have a question on one half of the page and it's blank on the other half. And I have very minimal information on each of the slides themselves. That's because I actually want you to hear what I'm saying a lot of the time as opposed to actually writing when we're in class. So when we're looking at all these notes, like on this first slide, it says, what is chemistry? And then I have a definition there. But that definition is very minimal. I'll go into some long-winded explanations about some things. Lucky for you, if you're at home, you can fast forward when I get rambly, and I apologize now. I do that occasionally. But the question will be given, the actual definition or the answer will be given to you as well. All you have to do is write that down. In your notes, you can write as much or as little as you want to. I never collect them. Some people don't write notes at all. That is totally up to you what you want to do. So, again, I get long-winded. Just trying to make sure that you're successful for the class, so I apologize. But as far as the class itself, chemistry. Chemistry is the study of matter and the changes that matter undergoes. So as we look at matter, we're going to have to define what is that, and then we're going to change that matter itself. I'm going to get ahead of myself just a little bit, and matter is stuff. Anything you can see, feel, taste, touch. It's anything that has mass and takes up space. So with your matter itself, we're going to take stuff, just general term, and we're going to change it in many different ways. Sometimes it's going to be a chemical change, as you're going to find out what that is later on, or sometimes it's a physical change. But we're going to take stuff and we're going to change it. Chemistry is not biology. Chemistry is a different part of your brain. Normally I say if you don't like biology, a lot of times you'll end up liking chemistry. It is math-based, so we're going to have a lot of math second semester. That's why I always recommend you have a calculator in your possession. So if you didn't purchase a calculator, you might want to. We have a class set of these in the classroom itself. Second semester is a lot more math-based than first semester. And that is also why you should be enrolled in Pre-AP Algebra 2 at the same time as this class, because Mr. Fesky actually takes the class itself, and he does a lot of the math for me. So he teaches you the math terminology, and then I just say, okay, here's it in terms of chemistry. So as we look at the different math topics, it is very math heavy. I always kind of joke around and I say that chemistry is algebra with fire and bubbles. It is not geometry. It is an algebra-based class. So a lot of formulas and things like that. So we're going to get a lot of basics done first semester. Second semester, we're going to apply a lot of the math. Second semester is a lot more interesting to me, especially because we do take the math concepts and it helps to kind of go through the different concepts and explain it a little bit more in depth. So you're going to look at a lot of the things in the world around you and you're going to go, oh, that makes a lot more sense now. That happens a lot as we go through this class. It is not biology in the sense that we do not dissect anything. Everybody always asks, when do we dissect a frog, or when do we dissect a bird, or whatever? That is biology. That is not chemistry. However, with your chemistry, it is the central science. So your first unit in biology was chemistry. You learned about pH and you learned about, I always remember Miss Cheney, she would talk about CHO, like CHO, like carbon, hydrogen, oxygen. I don't remember why you guys chanted those, but I remember like CHO and Chan and John P. maybe, but I remember all of those because you do have all these different topics in biology that you need to know. So you have to know chemistry in order to do biology. You also have to know chemistry in order to do physics. A lot of schools do chemistry first and then you do biology and then physics the next year. We just do biology first and the biology teachers teach you a little bit about it. But second semester, there's this weird mix-up between chemistry and physics where I'm going to say, okay, we're going to learn a little bit about this year, but you're going to get more in depth next year. That happens a little bit first semester too, especially when you get into like the flame tests and electrons. They're going to jump and they're going to create a light, and we're going to talk a little bit about the light, but you're going to talk more about it in physics. If you are going into medical school, nursing school, if you want to be a physician's assistant, anything in the medical world, a pharmacist, chemistry is your new best friend. You're probably going to go to get your undergrad and you're going to major in biology or chemistry and then minor in the opposite. Sometimes you have some different things that you do, but if you're going into the medical world, chemistry is your new best friend. Same with engineering. You need to know a lot about engineering or chemistry in order to do engineering. Even rocks, people are like, I'm going to take, geology. I don't really like chemistry. There's actually a lot of chemistry in that geology. So pretty much in order to do any science, you have to know the chemistry that's in the middle. It is considered to be the central science because it does touch all other forms of science. So with your different branches of chemistry, this is just extra information. So with that extra information, people always talk about, biology. I'm using that as a reference because you did take it last year, so it should be the most fresh in your brain. But you have different forms of biology. If you study biology, that's an overall concept. It's like saying cars, but then there's a Ford and a Chevy and an Aston Martin and a Lamborghini. You know, there's all different types of cars. The same thing happens with biology. There's all different types of biology. You can go to school and you can study just ichthyology, which is the study of fish. You can go to school and you can just study mammalogy, which is the study of mammals. You can go and study just insects, just cells. You can just study, I don't even know, xenobiology, the study of aliens. You can do all these different things in biology. The same thing happens in chemistry. Pretty much the two different types of chemistry, or organic and inorganic, and everything else kind of falls under those concepts. But basically it breaks down to, does it have carbon or does it not? If a compound has carbon, it's called organic chemistry, which if you're going into the medical field, you're going to learn that your organic class, either you love it or you hate it, and it's probably the most difficult thing you're going to take in college. Inorganic chemistry does not have carbon-based. So anything that's alive is organic, anything that is inorganic does not have carbon. So water is an inorganic substance, H2O, it just has hydrogen and oxygen. Or anything that you studied in biology, like the CHO, CHON, CHONP, the C, that's your organic compound. You also have analytical chemistry. Analytical chemistry was actually one of my favorite ones to do, where you're just taking the chemical makeup of whatever it is and you're breaking it down smaller. You can do that with foods, you can do that with compounds. There's all different things that you can do with analytical chemistry, but it's a very math-based concept, and that's where I really liked to be. Biochemistry is kind of the biology and chemistry mix-up. It is an organic type class because it's living things, but you actually, if you're a science major, a lot of times you have to take biochemistry. I took it in my biology coursework and I took it in my chemistry coursework. I had to take it twice with two different viewpoints on it. Thermochemistry, we're going to do an entire unit on it second semester, but that's looking at heat in chemistry. So we're going to burn things, we're going to light things, we're going to make things get hotter and colder and everything else, but it's just looking at the heat transfer in chemistry. And then environmental chemistry is the chemistry of the environment. If you take AP environmental here, you're going to have a lot of that. We touch on it. I try to hit it when I can and kind of embed it because it's not actually in the class, but I try to talk about it here and there. So this is extra information. You don't need to know any of those. I'm not going to ask you anything like that on a test, but I just kind of wanted to let you know that there is different types of chemistry. We're going to hit on those as we go throughout the year. So just a couple definitions today, and then I promise I'm done. But we said that chemistry is the study of matter and the changes that matter undergoes. So as we look at what is matter, the definition is anything that has mass and takes up space. So as we look at anything that has mass and takes up space, it is anything that is a solid, a liquid, or a gas. Those are the three states of matter that we care about for this class. Other states of matter, there's like 12 of them, we don't need to know for this class. Solids, liquids, and gases. Those are the states of matter. So if it is a solid, a liquid, or a gas, it will have mass, it will take up space. If I asked you to give me an example of matter, which in class we would call these out, you could say your desk, your pencil, your water in your water bottle, the coffee that's sitting on my desk, a glass of iced tea. And then somebody will say air, and then somebody says, not air. Air doesn't have mass, but it actually does. If you blow up a balloon and you take the mass before and after you blow it up, once it has air in it, that balloon weighs more. It has a greater mass. It does take up space as well. If you take a big breath in, it's taking up space in your lungs. So anything that is a solid, a liquid, or a gas is going to have a mass and it's going to take up space. The gases is what gets people. When we talk about things that are not matter, you go, gosh, I don't know. Is there anything that doesn't have mass, doesn't take up space? Those are the things that you talk about in physics. Those are forces and energy. So like gravity is a force. It's what holds your seat to your your butt to your seat, which pulls you towards the center of the earth. Gravity has a mass, or does not have a mass, sorry, does not take up space. So gravity is not matter. Electricity, light, sound, all of those things are a form of energy that is not considered to be matter. Time is made up, it doesn't really exist. Random thought about those little TikTok videos with the time. Time does not actually exist. It was made up by humans. So with the time itself, it doesn't have mass, it doesn't take up space. Thoughts in your brain are electrical impulses. That is not considered to be matter because they're not real. Color is light that is reflecting back. It doesn't have mass, it doesn't take up space. So anything that's an energy or a force is not actually considered to be matter. Now, with another definition that you're going to see a lot this year, and one that was in the definition of matter, matter is anything that has mass and takes up space. Mass is how much stuff, how much matter is actually in something. A lot of times people don't like this definition because you can't have matter without mass. You can't have mass without matter. It kind of is all cyclical. It is what it is on this one. So it's just how much stuff is there. Which is going to lead us into density as well, how much space is in a given amount of space. But this is just how much stuff is physically present there. So how much matter is in something. That is actually different than weight. You're going to use this distinction in physics. We kind of use them interchangeably in chemistry, but weight is technically different. Mass is measured in grams, weight is measured in newtons. And your weight will change depending on how much gravity is pulling down on you. So my weight is different here in Houston versus in Colorado because you have a different amount of gravity pulling down on you. The same thing with my weight here versus my weight on Mars. If I go to Mars, my weight is going to be different because there's a different amount of gravity on both of those two places. My mass, though, is the same, barring I don't lose a finger in space, I don't use the restroom, I don't lose blood, things like that. But my weight will change because it's how much gravity is pulling down on something. Mass, how much stuff is there, is always going to be the same. So depending on where you are, I just said this, your weight is going to change. Your mass is always going to stay consistent. This is a technical difference between the two. However, I just wanted to make sure that you did know that they are technically different because they're going to get into that in physics. That is actually where we're going to stop for the day with your notes, and tomorrow we'll pick up with scientific notation. So I'm going to stop this video and then we'll go on with a different video tomorrow.